All right. So segment proofs is what the lesson is for today. We've got a lot of properties of congruence to talk about, though, because this is the stuff that we're going to use to be able to prove things. Now, yesterday we went over in class a lot of things about algebraic properties of equality. So remember that you've still got all of these at your disposal to use in your proofs, okay? So we're going to do segment proofs today, so we need some more properties for segments, and then you're also going to have to remember that you can use these as well to prove your case as to why something is true. So let's get into the properties that we're going to use. Reflexive property of congruence. For any segment AB is congruent to AB. All right, so it's saying that things are congruent to themselves, which it seems kind of trite right now, but this is actually a really useful thing, especially when we get into similar triangles, proving that things are similar. I want to be able to say that this side is similar to itself, or congruent to itself for my proof, okay? And this is going to be a little bit later on, I think chapter 5 or 6, that we get into stuff like this. But this pops up for the rest of the class. Learn it and love it. So your symmetric property of congruence, if you've got a segment AB congruent to another segment CD, then also CD is congruent to AB. So it doesn't matter which order I say things are equal to themselves or congruent to themselves is. If it works this way with congruence, then it also works the other way around, which is really handy, because if this didn't work, we would live in a nightmare, and it wouldn't be pleasant. But anyway, so transitive property of congruence. If AB is congruent to CD and segment CD is congruent to segment EF, then AB is congruent to EF. Because AB is congruent to CD and CD is congruent to EF, then I can say that AB is congruent to EF. This is similar, well, it is your transitive property of congruence. You saw it in algebra. If A equals B and B equals C, then A equals C. But here we'll say AB is congruent to EF. So there's just some properties of congruence. So definitions. Definitions are important. They tell us what things are and how we can use them. So segments are congruent if and only if they have the same measure. So if AB is congruent to CD, then AB is equal to CD. And if AB is equal to CD, then AB, segment AB, is congruent to segment CD. So definition of midpoint, you're going to use this one a lot as well. You're going to use all of them. Just learn them. So the midpoint of a segment divides the segment into two equal congruent parts. If M is the midpoint of AB, then AM is equal to MB. All right, so here's A, there's B, and there's my M. So that's congruent to that. All right, so segment addition postulate. If A, B, and C are collinear points and B is between A and C, then AB plus BC is equal to AC. Alright, so this practice sheet that we've got here, we're going to justify each of the following statements using one of the properties of equality, properties of congruence, definitions, or postulates. So this just requires you to look back at your definitions and figure out which one is which. All right. So if PQ is equal to PQ, then segment PQ is congruent to segment PQ. That's your definition of congruence. Alright, so if K is between J and L, then JK plus KL equals JL. That's your segment addition postulate. Alright, so we could go through the rest of these and identify which is which, but we're not going to right now. I want to get into some segment proofs. But this is an important skill. You've got to learn to recognize these things. So you're going to get more of this on this page, segment proofs. So we're going to complete the proofs below by giving the missing statements and reasons. So make sure you read the entire thing before you go bananas and trying to figure it out. So given that E is the midpoint of DF, so let's go see what we've got. E is the midpoint of DF. So right when it says midpoint, you should start thinking about what does midpoint mean? What's that going to tell me about this line? How's it going to help me out? All right. So I'm just thinking out loud. It's told me that E is the midpoint of DF, so I'm going to go ahead and, just so I can remember later, DE is congruent to EF. I'm going to mark it. So we want to prove that 2 times DE is equal to DF. So 2 of these is equal to the whole thing. Well, that makes a lot of sense, doesn't it? If DE is congruent to EF, then I can just know the measure of this one and multiply it by 2, and it's going to give me the whole thing. So here are our statements of what's going on, of how we've proven that that is the case. We are responsible for giving the reasons over here. So our reasons are the rules and the definitions on the other pages that you can refer back to do these things. You don't have to have all these things memorized. You've got to know where to find them at. So here we go. E is the midpoint of DF. Look up here. E is the midpoint of DF. That's your given. Your given is generally going to be your first statement. You can have more than one given as well. You can have given here, and you can sometimes have another given. All right, so what have we got here? DE is equal to EF. So DE is equal to EF. Well, that is the definition of the midpoint. So, since DE is equal to EF, that's our midpoint, we can add DE plus DE, 2 of these, and it's going to equal the same thing as DE plus EF. So that is our addition property that we're using there. Add property. Because I have added the same thing to both sides. I started with DE and EF, and then we added DE to both sides. So DE and a DE, that's how we got this statement. Alright, so 2DE is equal to DE plus EF. How did we get, what's the difference between here to here? How did we come from here to here? We simplified our problem. So I added these two together and just wrote it down as a statement down here. Alright, so DE plus EF is equal to DF. What happened here? What happened between this step and this step? We used the segment addition postulate to say here that DE plus EF was equal to the whole thing. So DE plus EF was equal to this. So segment addition. Alright, So after I did this, DE plus EF gives me the whole thing. I'm going to refer back up to this one. I had 2DE is equal to DE plus EF, and that gives me that 2DE is equal to DF. So there's your transitive property. Alright, so there we have proven that twice DE is equal to DF. And these are the steps, or the reasons why we can take these steps. You all already know how to do this. It's just getting in the habit of writing it down, your reasons why you can do them. And I know that's kind of quick. You don't have a whole lot of opportunity to ask me any questions through this format, but we'll do the best that we can with it. Alright, so KL is congruent to LN. So KL and LN are congruent. And LM is congruent to LN. So look at that. All three of these lines are the same measure. So we're going to say that L is the midpoint of KM. So here we go. We've got this statement. That is our given. That's where we're starting from. It's always the first thing is your given. So now we're going to say KL equals LN, LM equals LN. This is your definition of congruence, how you can switch these signs to equal signs from the definition of congruence. Alright, so KL is equal to LM. So look what these have in common. They've both got LN in common with each other. So what are we using? KL equals LN and LN equals LM. Well, that's this statement without the LN. So we're using the transitive property to say that they are congruent to each other, or equal to each other. So L is the midpoint of KM. Well, that is the definition of midpoint. Alright, so don't think that because I'm going through these statements really fast that I'm thinking of these solutions that fast. I assure you I am not. If I didn't have my answer key, I would not be going through these that fast. Okay, so if you can't think of the reason right off the bat, don't fret. Just give it a minute, go back and look through your definitions and your postulates and your theorems and think about what's being asked and what you're trying to get to, and see if you can find one of those things that's going to help you get from point A to point D. Okay, so don't think that because I went through it that fast I was thinking of the answers that fast. Some of you might be able to. I'm telling you, I can't. It takes me a few minutes to think of these things as to what's going on and decipher each one of these little things. So don't let that you're not coming up with them worry. So we'll do this one last one here, and I'm going to go through this one even quicker. All right? And you can look through and convince yourself that this is the truth. I think that will actually help you learn how to do these things better, is if you study the proof on what they're doing and the steps that they're taking to get through to it. Alright, so what I want you all to do the rest of the class period is to try to do problems 4, 5, and 6. Alright, attempt them. If you can't get every single one of the steps, do what you can on each one of them, and then on Thursday we'll start back up with these and we'll go from there. because I believe that quiz that you all took is probably going to eat up most of your class time. All right, y'all have a good one. We'll see you tomorrow.